Welcome. Thank you for being here to learn about Mobility Master Plan Area of Focus Number 4, Managing Road Capacity Strategically. My name is Sarah Grady. I'm a Traffic and Transportation Engineer and a manager in the city's Transportation Planning and Design Division, and I'm part of a multidisciplinary team working on the Mobility Master Plan. In this short video, you will learn about some of our mobility goals for the future, as well as policies and actions that can help us achieve them. Before we get into what we can do going forward, I want to take a second to highlight one of the recent projects we've been working on to manage road capacity and minimize delays. Many of us can remember waiting in long lines of traffic at the rail tracks in Adelaide waiting for a train to pass. Those days are now behind us with the new Adelaide Street North Underpass, which recently opened to 2 lanes of traffic and will be fully operational later this year with 4 lanes of traffic, wide multi-use paths on both sides of the street, and improved transit amenities. This project will directly improve safety and reliability by eliminating the at-grade rail crossing, reduce cut-through traffic in nearby neighborhoods, and improve active transportation and overall quality of life. Now let's take a look at some of our specific goals for the Mobility Master Plan. Similar to at-grade rail crossings, intersections can also interrupt the flow of traffic. To improve our roadways, operational and multimodal improvements will be considered to increase the people-moving capacity of our corridors and manage travel demand and delay without having to build more general traffic lanes. This may include intersection improvements, lane reconfigurations, signal timing adjustments, high occupancy vehicle lanes, transit service improvements, sidewalks, cycling facilities, and land use solutions that help shorten trips. For example, at intersections with operational concerns, including long delays, roundabouts can be considered as an alternative to improve traffic flow and minimize idle time. Roundabouts can also be a safer alternative to traffic signals and stop signs. The tight circle of a roundabout forces drivers to slow down, and the most severe types of intersection crashes are significantly less likely. Another example of an operational and multimodal improvement which manages travel demand and delay without the need for new general traffic lanes is a lane reconfiguration. On the right is an example of a lane reconfiguration which was completed in Ottawa on Main Street. A lane reconfiguration is a transportation planning technique where the number of travel lanes or the effective width of the road are reconfigured in order to improve the overall mobility system in the area. The most common lane reconfiguration is the conversion of a 4-lane road to a 3-lane road made up of 1 through lane in each direction and a center to a left turn lane. Recaptured space from the reduction of lanes allows the roadway cross-section to then be reallocated for other uses such as bike lanes, pedestrian refuge areas, transit uses, or parking. So why consider a lane reconfiguration? Let's take a bit of a closer look at the example of a 4-lane conversion to a 3-lane. Lane reconfigurations can improve safety. They reduce vehicle-to-vehicle conflict points. So a conflict point being where the path of a vehicle has to cross the path of another vehicle. The more conflict points you have, the more likelihood there is for collision. And of course, less conflict points makes a collision less likely. So looking at the example in the top right, the 4-lane undivided section, a left-turning vehicle would have to cross 2 lanes of traffic to make its left turn. So that creates 2 conflict points. Versus in the 3-lane cross section, the vehicle only has to cross 1 lane of traffic. So it reduces the number of conflict points to 1, therefore making that movement safer. Another benefit of this reconfiguration is that the sight lines are improved. So again, looking at the 4-lane divided cross section, they're crossing 2 lanes of traffic again, and it can be difficult to see in the far lane of traffic and find gaps in those vehicles to make your turn when your line of sight is blocked by vehicles in the close lane. Versus again, looking at the 3-lane cross section, there's only 1 lane of traffic you're crossing, and there's not going to be other vehicles in your way that impede your view. Overall, studies have shown that this type of lane reconfiguration results in a 19 to 47% reduction in crashes. These types of lane reconfigurations also have operational benefits. Separating left-turning traffic reduces delays at signalized intersections and produces a more consistent flow of traffic along the corridor with less slow and go by getting stopped behind turning vehicles. It also makes it easier for side street traffic to enter the roadway more comfortably because there's fewer lanes of traffic to cross. There's also a number of pedestrian benefits to these reconfigurations. 3 lanes of traffic are much easier for pedestrians to cross than 4. Speed reductions associated with the improvements lead to fewer and less severe crashes. And lane reconfigurations often include either bike lanes or sometimes on-street parking, which acts as a buffer between the motor vehicle and the pedestrians on the sidewalk. And since lane reconfigurations often include the addition of bike lanes, there's clear benefits to cyclists. Formerly stressful streets can be transformed into comfortable routes, attracting more cyclists. Cyclists are more visible, and motorists know where to look for them when there's striped bike lanes present. And if space is available, the buffered bike lanes or protected bike lanes can offer an additional visual or physical barrier between cyclists and the motor vehicles. Another important part of managing road congestion and ensuring equitable use of public space is curb space management. There is a high demand for curb space, including pickup and drop-offs, bike lanes and transit stops, commercial loading zones, short-term parking, and electric vehicle charging. Developing curb space management strategies will help manage road congestion and make curb space safe and accessible for all road users. Speaking of commercial loading zones, we also need to consider the movement of goods in the context of the larger mobility system. The efficient delivery of products is crucial to the satisfaction of the customer, the success of individual businesses, and the local economy. Developing a strategic goods movement network will help make the movement of goods more efficient, modernized, and balanced with the needs of other road users. So, in short, London's mobility system needs to support the movement of both people and goods to all areas of the city. Through the Mobility Master Plan, we are identifying initiatives that strategically maximize the use and efficiencies of our corridors, manage curb space, and support the movement of goods. Thank you for listening, and we invite you to learn about all 8 areas of focus for the Mobility Master Plan and share your feedback with us.